इसको देना इंटरनेट कोड। Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy. Just one moment. Alright, so let me start with my introduction. I am Jeetendra Dixit. I did my BTech from IIT Kanpur and I have been mentoring IIT-JEE aspirants for last 11 years. I teach mathematics and we were doing, in today's session we are going to do complex numbers, cube roots of unity. Okay, so I'll discuss cube roots of unity and then next session we'll do nth roots of unity. Alright, so let's cover cube roots of unity in detail today, all the theory part and some questions. But before the starting, let me tell you about the Unacademy subscription. So as you know, Unacademy is India's largest online learning platform, and you can have two kinds of subscription on Unacademy. One is Plus subscription, another is Iconic subscription. So I'll tell you about both the subscriptions. In Plus subscription, you get daily. When you get Plus subscription, you get access to daily live classes of all the educators, all means all physics, chemistry, and maths. You can attend their live sessions as well as recorded sessions. So if you miss something, you can download their recorded sessions and watch those sessions offline also. All right. And other than that, during the live session, you can interact with your educator through chat. You can ask your doubts by sending the images or typing your question, and you can participate in polls. So these lectures are very interactive. You can attend the special classes which are completely free. So every day, many educators take special classes on the platform, which anyone can attend even without getting any subscription. So you can attend those live classes, live sessions of special classes. All right. So you download the application and you will see there's one tab for special classes. You just click on that. You will see all these special classes live going on every day. So attend those classes. You'll get and live tests and quizzes will also be accessible to you once you get the subscription. So all India test series you will be able to access. Structured courses means all these courses which are going on Unacademy are well structured. You can follow any course by the team or individual educator. That's up to you. So you get unlimited access and there's no restriction on that. These are the charges for Unacademy's Plus subscription. For 12 months it is 38,500 and for 24 months it is 56,000 and 56,000. You get 10% discount if you use my code. So use this code JEET1 and you'll have to pay only this much. So you'll get 10% discount in this price. All right. So final price will be 34,650. Similarly for 2 years also, in all the subscriptions you'll get 10% discount if you use this code JEET1. So use this code and get 10% discount instantly. Now let me tell you about the Iconic subscription. So what is this Iconic subscription, which is added recently? So in this subscription you get all the benefits of Plus. All means whatever I was telling you just now, you'll get all those things, all the things, all live classes, tests, quizzes, everything will be accessible to you if you get Iconic subscription also. Apart from that, you get a personal coach. You can see you get a personal coach. That means an expert who will guide you throughout your preparation. So if you have a 1 year subscription, so you'll get 1 year personal guidance of an expert for all your top exams, for advanced, for main, for bids. All right. Your test analysis will be done in a personalized manner. Your feedback will be given to improve your time management and exam approach. And similarly, study planner will also be customized. All right. And by weekly reviews and highlights will be given to weekly reviews will be given and highlight, and that will highlight your progress. All right. So this is what you get when you Iconic subscription, and you'll have to pay 6,000 for 1 year subscription, Iconic subscription, and you get 10% discount using this code. Use this code Jeet1, you'll get 10% discount, and it is, it will be 50,400. Now for 2 years it is 86,000, and again in this price also you'll get 10% discount. All right, if you use my code Jeet1, so you'll have to pay 77,400 only. So I hope these things are clear. Let me check my voice. Okay, perfect. So you can download this Unacademy's learning app from Play Store and just start attending special classes until you haven't bought any subscription. All right, you can attend unlimited special classes. So just start your learning today. All right, now we are going to do cube roots of unity, right? So I'll tell you how to do cube roots, how to find cube roots of unity. So basically, we are finding the roots of all right. So in cube roots of unity, you need to solve this equation. X cube is equal to 1. All right. So if you take cube root, you'll get three values of three values of cube roots of unity, and those three values, what will be the values? Let's solve it. So this is because it's just a 3-degree polynomial, so we can solve it, all right, by factorizing it. So first I'll tell you one method using just factorization. No complex numbers. I mean, no method of complex numbers. So x cube, we can factorize this, right, by applying the formula of a cube minus b cube. So it is going to be x minus 1, and then we'll get x square plus x plus 1. All right. So you can see we have got one root, and one root is 1 only, right? So what? Yes, obviously 1 is one of the root of x. Any like you are finding cube roots or fourth roots or fifth root or nth root will always be 1, right? Now what are the remaining two roots? So remaining two roots. Remaining two roots will be the roots of this equation, this quadratic, x square plus x plus 1. Okay, so this is also an important point. In many places you'll see that in the question it will be given that alpha and beta are the roots of x square plus x plus 1. All right. So remember this quadratic. This quadratic is very, very important quadratic, right? Quadratic. By factorizing x cube minus 1, you are getting this quadratic. That means x square plus x plus 1, whenever it is given that alpha and beta are the roots of this quadratic, that means that alpha and beta are basically complex cube roots of unity. All right. So remember that point. That's an important point. So what are the roots? Let's write the cube roots of that equation. So if you write the roots alpha and beta, I'm writing it together. So alpha and beta, just apply the formula. It is minus 1 plus minus under root of b square minus 4ac. So it is going to be minus 3 divided by 2a. So 2. All right. Then you can write minus 1 root 3 under root of minus 3. Root 3 can be written as root 3 into under root of minus 1 is iota. You know that. Divided by 2 and plus minus. So you'll get two values. All right. If I take one value as omega, okay, because cube roots of unity are generally represented by omega and omega square. It's not necessary. You can write 1 alpha and alpha square. You can use any symbol, but this is you can say one of the standard symbol which is used for cube roots of unity. All right, but it should be mentioned in the question. You can't assume it automatically. All right. Somewhere if some equation in omega is given, then you can't assume that it's a cube root of unity. Okay, so omega is minus 1 plus root 3 iota by 2. That is one thing. Now if you take this value as omega, then second value will be basically square of this. If you square this, then you get minus 1 minus root 3 iota. by 2. Okay, you can do that. You can square it. You can square it minus 1 plus root 3 iota by 2 the whole square. So you'll get 1 plus 1 minus actually 1 minus 3 minus 2 root 3 iota divided by 4. All right. uh, then minus 2 and minus 2, 2 will be common and 2 will get cancelled. So it is going to be minus 1 minus root 3 iota by 2. So you have got this value, right? That means these are basically, if you square the first one, you'll get the second. If you square the second one, you'll get the first. If you do the squaring of this, that means omega raised to 4, that will become omega, all right? So anyways, you need to remember these values of omega and omega square. These are the values which we have got by factorizing or by applying the formula of quadratic equation, Jeetenra, all right? So these are cube roots of unity, 1, omega and omega square, okay? If I try to plot these values, then see, there are many other relations. I'll come to those relations. You just need to remember first of all these three values, all right? 1, 2 and 3. Is that okay? Okay. If I plot these values, then see how this diagram will look like. Just take this circle of unit radius. Whenever you are finding the roots of unity, no matter it is cube root or fourth root or fifth root or nth root, all these roots will lie on the circle, on the circumference of the circle, whose radius is 1 and center is origin. Okay? Whose radius is 1 and center is origin. So one root you can see is 1. This is 1 first root. Second root omega will be here. This is minus 1 in second quadrant, minus 1 minus 1 plus root 3 iota by 2. This is second root, which is omega. And this will be the omega square, which is basically conjugate of omega square is basically conjugate of omega. You can see, right? You can see this plus sign is changed to minus sign. So omega and omega square are basically conjugates of each other. You can write omega bar is equal to omega square. And because omega is of unit modulus, omega bar can also be written as 1 upon omega. You know, z bar is 1 if mod z is 1, right? Z bar is mod z square. So z is equal to 1 upon z bar, or z bar is equal to 1 upon z if z is unimodular. So here omega and omega square are unimodular. So omega bar can be written as omega square as well as 1 upon omega. So I hope you have got this, all right? Z bar is equal to mod z square, and if mod z is 1, so you can write z bar is equal to 1 upon z. This is what I'm using, okay, here. All right, so omega square will be equal to minus 1 minus root 3 iota divided by 2. So you can see these are the roots. If you check this angle of this vector with positive direction of x-axis, then it is going to be 120, all right? And if you check this angle, then this angle is also going to be 120, and the remaining third angle will also be 120, all right? So if you join these 3 points, they are basically dividing the circle into three equal parts, and that happens in all the roots of unity. Whether if you take fourth roots of unity, that these 4 roots will divide the circle into 4 parts. That means angle between any 2 complex numbers will be 90. Consecutive, basically consecutive, I should say consecutive. So if you join these 3 points, then these 3 points will form an equilateral triangle, right? So if you have 4th roots, then they will form a square. If you have 5th roots, then if you plot 5 roots, they will divide the circle into 5 equal parts. And if you join these 5 roots, you'll get a pentagon, regular pentagon, all right? So they will always form a regular polygon, okay? So whenever you are finding nth roots of unity, they will always form a regular polygon. I hope this point is clear. So this geometrical point will be clear when I'll tell you another method of doing so. Now I'll tell you the second method. So this is a generalized method, method 2. And this method you can use to find nth roots or fifth root or sixth root or of unity or any other complex number as well. All right. So let's see what is this method. X cube is equal to 1. All right. Now, whenever you are taking a cube roots of unity or any other complex number, or like you can take cube root of iota also. We'll take today only. So if you're taking the cube roots of 1, then 1 should be this complex number, whatever this complex number is. It should be written in Euler's form. An angle, Euler's form is r e raised to I theta. Theta should be the general angle. That means theta plus 2k pi. All right. So 1 can be written as 1, modulus of 1 is 1, and argument of 1 is 0, and general argument is 0 plus 2k pi. So basically 1 can be written as e raised to iota 2k pi. So in this form you need to represent the complex number written here, right hand side of the equation. Then we will take cube root, okay? So we'll get 3 values in Euler's form only. So let's write this, e raised to I 2k pi, where k belongs to integers. All right, k belongs to integers. Now if you take cube root, if you write x, it is going to be e raised to iota 2k pi by 3. Okay, and k belongs to integers. Now if you start taking values of k from 0, you can start from any number, but let's start from 0 here. If you take 3 values of k, consecutive 3 values of k, you'll get 3 distinct complex numbers, and then these complex numbers will start repeating once you cross these 3 numbers. Okay, so when k is equal to 0, you'll get your first root x1, and x1 is going to be e raised to iota 0, which is nothing but 1. All right, the second root x2 is when k is equal to 1, and when k is equal to 1, its second root is going to be e raised to iota 2 pi by 3, and this was basically omega. Do you remember that? The omega was at an angle of 120 degree. This was omega. And then when you put k is equal to 2, then you'll get x3, third root, and third root is going to be e raised to I 4 pi by 3. So whose argument was 4 pi by 3? Omega square. So 1 omega and omega square, these are the cube roots of unity. Now it is very easy to see that yes, these 3 complex numbers are equally inclined to each other. Equally inclined, are you getting this point? What am I saying? Equally inclined. That means angle between any 2 consecutive is 120. Angle between any 2. Difference of argument of any 2 consecutive is 120. So first is 1. Second you can see is e raised to I 2 pi by 3. So this angle is 2 pi by 3. And third is e raised to I 4 pi by 3. So this angle is 4 pi by 3. 4 pi by 3. This is your omega. This is your omega square. And this is your 1. So now finally we have got the roots 1, omega and omega square. And we know 1 can be written as 1 only. Omega, what was the value of omega? You need to remember that. Minus 1 plus root 3 iota divided by 2. And what was the value of omega square? Minus 1 minus root 3 iota by 2. And another way of writing these 3 roots is Euler's form. So 1 is 1 only, or you can write e raised to I is 0. So no matter, no need to write that. Write 1 as 1. This is complex values you need to. This one is e raised to I. What was the angle? 2 pi by 3. Okay, 120. And what was the angle of this? E raised to I 4 pi by 3. So I hope you have got it. So in this way, you can take cube roots of unity. Now I'll write the relations. All right. Now I'll write the relations. So first relation is very simple. Sum of all 3 roots 1 plus omega square will always be 0. Very, very important relation. All right. There are many ways to understand it. You see, these are the roots of x cube minus 1 is equal to 0. So sum of the roots, if you find the sum of the roots using the formula of polynomial relation of the roots, sum of roots, then that will be minus of coefficient of x square divided by coefficient of x cube, right? So in this way you can write coefficient of x, because x square is not there, so coefficient of x square is 0. That will be 0. 1 way. So in this way you can write sum of the roots is 0. Okay, this is one way. Second is, you know the roots, so you add them. So if you add 1 plus, what was the root? Minus 1 plus root 3 iota by 2. And next will be minus 1 minus root 3 iota by 2. So that will be again 0. And this way also you can. And the third way is that these are basically vectors of equal magnitude and equally inclined to each other. So sum of vectors which are equally inclined to each other, as well as they are of equal magnitude, their sum is 0. So there is one, there is another vector. So using vectors also you can say they will cancel each other. This is omega and this was omega square, right? So 120, 120 and 120, and all three are of magnitude 1. So they will cancel. So in this way also you can say 1 plus omega square. So this is a very important relation you need to remember. And the next one is omega cube is equal to 1. Okay, omega cube is equal to 1. I just forgot to mention that if you put k is equal to 3, then you'll again get the same value which you are getting for k is equal to 0. If you put k is equal to 4, then you'll get again the same value which you are getting for k is equal to 1. Okay, so these three values will keep repeating if you keep repeating the integers. All right, I mean if you keep increasing the integers, 1 omega square, 1 again omega square, 1 omega square, and so on. All right, so omega is cube roots of unity, so omega cube should be 1, right? If you put omega in this equation, it should satisfy. So omega cube is equal to 1. So these are two very, very important relations which you need to remember, all right? Hmm. Now suppose if I ask you to find the roots of, okay, first let me tell you some more points related to omega, then we will continue. Okay, so far we have got these two relations, 1 plus omega square is equal to 0 and omega cube is equal to 1. What will happen if you write omega raised to 4? So you know omega cube is 1, so you can write omega raised to 4 as omega cube into omega, and that will become only omega. So omega raised to 4 is omega. And then omega raised to 5, if you write, that will be omega cube into omega square. Omega cube is 1, so you'll get omega square. If you write omega raised to 6, so that is omega cube square. That means it is 1. So if you have omega raised to 7, then it will be again omega raised to 6, which is 1. We have just got, right? And into omega. So it is omega. So, these values are repeating. That's what I was telling you. That whenever you have omega raised to 3k, it's a multiple of 3. Omega raised to 3, omega raised to 6, omega raised to 9, omega raised to 12. It is going to be 1. All right. If you have omega raised to 3k plus 1, 3k plus 1 means if you divide by 3, remainder should be 1. Like 4 is 3k plus 1, 7 is 3k plus 1. Then answer is going to be omega, because you can write omega raised to 3k plus 1 as omega raised to 3k into omega. So omega raised to 3k is 1, omega will be remaining. Now similarly, if you have omega raised to 3k plus 2, it is going to be omega raised to 3k, which is 1, and omega square will be remaining. Okay, so if you have any three consecutive powers, on omega, then these powers will give you values for 1, omega, and omega square. And if you add them, like omega raised to 3k plus omega raised to 3k plus 1 plus omega raised to 3k plus 2, so that is going to be, this is nothing but 1 plus omega square, and it is 0, right? Like for example, if I write omega raised to 51 plus omega raised to 52 plus omega raised to 53 plus omega raised to 54 plus omega raised to 55 plus omega raised to 56. Okay, what is this value? So these are three terms which have three consecutive powers in addition, of omega, terms of omega, and these are again three consecutive terms. I mean terms of omega with three consecutive powers. So this is going to be 0 and this is going to be 0. One of this will become omega, other will become omega square, and then remaining third will become 1. All right. So it is going to be 1 plus omega square. All right, getting this? 1 minute. Hi, Adya. Got it? Okay, so I hope you got this point. Now, suppose I give you one example. Suppose you need to find this value. What is this value? Think about it. Solve it for a moment. Then I'll tell you. Use those two relations, simple relations. You can answer it easily. All right, so let's use it. 1 plus omega square is equal to 1. So you can write 1 plus omega square. Whenever you have 1 plus omega, you always write it minus omega square. Whenever you have 1 plus omega square, you write it minus omega. So 1 plus omega square can be written as minus omega, or 1 plus omega can be written as minus omega square. All right. So now you see 1 plus omega square in the first term can be written as minus omega, and already you have minus 1 omega. So minus omega raised to 4. In the second one, you have 1 plus omega, which can be written as minus omega square raised to 4. Okay, write like this. Then you need to write this will become minus 2 omega raised to 4. So it will be 2 raised to 4 and omega raised to 4. All right. And the second one you will get minus 2 omega square. So raised to 4. So that will become 2 raised to 4 and omega raised to 8. Got it? Now you can take this 2 raised to 4 and 16 common, and it is going to be omega raised to 4. Omega raised to 4 is nothing but omega, and omega raised to 8 will be omega square. All right. So one of this term will become omega and other will become omega square. So now this omega plus omega square. Now what to write this omega plus omega square? So whenever you have omega plus omega square, you can write this minus 1 using the same relation. 1 plus, oh, there is 0, sorry. 1 plus omega square is equal to 0. We are using this. So omega plus omega square is equal to minus 1. If you put this, then it is going to be minus 16. Okay. So your answer is minus 16. So you can see you have fourth power But fourth power is on complex numbers. Okay, so in complex numbers, it is not like this. If you have even power, then get positive answer. No, in complex numbers, whatever is the power, you can get complex number, you can real number, you can positive real number or negative real number, anything you can get. All right, so this was the answer. I hope you have got it. Now, second, again simple question. 1 plus omega square plus omega cube and so on. You need to find the sum of this series up to omega raised to 100. It's a very, very simple question. I just want to bring your notice to one particular point which I just mentioned in previous slide. I mean in slide of theory. Okay. So I told you that whenever you have 1 plus 3 consecutive powers on omega, then sum of these three terms will be 0. So you can see sum of first triplet, first three terms will be 0. Sum of next three terms will be 0, right? So you can make these triplets. How many triplets you can make? Consecutive triplets. I mean triplets with consecutive powers. How many triplets you can form? You can form 33 triplets, right? Up to omega raised to 99. Just divide by 3, okay? So remainder is 1. That means one term, leaving one term. You can leave the first term, you can leave the last term. Doesn't matter, all right? Plus. So last term you are leaving, all right? Last term. It will give the same answer which you are getting by leaving the first term, which is 1 actually, right? Okay. So this is going to be 0. This is going to be 0. I'm sorry. No. It will end at 98 because you have 101 terms. Okay, you are starting with omega raised to 0. 1 is nothing but omega raised to 0. Let me explain it again. You had 101 terms, so two terms will be remaining. Okay, two terms will be remaining because you need to divide 101. This 1 was nothing but omega raised to 0. All right, so you have 101 terms. So two terms will be remaining. Which two terms will be remaining? Your remaining two terms will be, I'll write it. So last triplet which you are getting is ending at omega raised to 98. Then omega raised to 97 plus omega raised to 96. And this omega raised to 99 plus omega raised to 100. These two terms will be remaining, all right? So sum of these all triplets will be 0. And remaining terms, just write the remaining terms. So omega raised to 99 is nothing but 1. Okay, I'll write in next step. And omega raised to 100. Now divide this by 3. So it's a 3k type. 99 is 3k type. So omega raised to 3k is 1. And this is 3k plus 1, of course. So omega raised to 3k plus 1 is 1 plus omega. Now this 1 plus omega, further you can write this minus omega square, and that will be the simplified form. You can't further simplify it. Okay, so answer of this is nothing but minus omega square, or you might have 1 plus omega in the options. All right, and this was one of the way. Second, you could do, it's a GP, so you can find the sum of GP. All right, the only thing is that common ratio should not be 1. Then you can apply the formula. If common ratio is 1, then all the terms will become equal, but that is not the case. So method 2 is 1 plus omega square and so on up to omega raised to 100. So how many terms you have? 101 terms. All right, remember that. So first term into common ratio is omega raised to 101 minus 1 divided by omega minus 1. All right, now what is this omega raised to 101? Omega raised to 1, if you divide it by 3, then it will be omega raised to 3k plus 2. This number is 3k plus 2. That will become omega square. Omega upon omega minus 1. All right. So if you cancel omega minus 1 by a square minus b square in numerator, you can apply. So it is omega plus 1. So you have reached to the same answer. Obviously, reached to the same answer. So this is another. You can find the sum of GP, okay? Or you can use that concept. The sum of any three consecutive terms will be 0. Term in any three terms with three consecutive powers, okay? Let me say it correctly. Got it, guys? Got it? Now suppose you need to find the roots of x cube is equal to minus 1, okay? So I'll tell you the equations whose roots, cubic equations, whose roots can be written in terms of omega. So if you find cube root of, say, any real number, okay, any real number, purely real, should not be complex, then cube roots of any purely real number can be expressed in terms of roots of cube roots of unity. I mean in terms of omega, okay? I'll tell you the general method, but before that, let's simplify it, okay? All right. So if you have x cube is equal to minus 1, then you can write either in Euler's form or you can factorize it, okay? So you can factorize, let's factorize x plus 1, it is going to be x square minus x plus 1 is equal to 0. So you'll get one value as minus 1, okay? Now if you write the roots of this, then roots will be 1 plus minus under root of root 3 iota, because you get minus root 3, root of minus 3, which is root 3 iota divided by 2. So you can see what are these values by the way. 1 plus root 3 iota by 2 and 1 minus root 3 iota by 2. Are you able to compare it with omega and omega square? Yes, of course. This is minus omega square and this value is minus omega, okay? So basically cube roots of 1 were 1 omega and omega square, and cube roots of minus 1 are minus 1 minus omega square. All right, just put minus sign in all the roots, in front of all the roots. That is valid in any such equation whose degree is odd. Like if you write x raised to 5 is equal to 1, then you get 5 roots of this equation, and then you solve x raised to 5 is equal to minus 1. Then these roots of second equation will be basically minus of roots of first equation, okay? So whenever n is odd, if roots of this equation are x1, x2, x3 and so on up to xn, then roots of x raised to n is equal to minus 1 will be minus x1, minus x2 and so on up to minus xn, okay? But there's condition, provided n is odd, otherwise this is not valid. If n is even, then that won't happen. That means if you're taking a square root of 1, it will be plus minus of 1, and a square root of minus 1, then it is not opposite. It is not just put by putting minus sign the roots of x square is equal to 1, you won't get the roots of x square is equal to minus 1, okay? Similarly, x raised to 4 is equal to 1 and x raised to 4 is equal to minus 1. Roots are not related, okay? Roots are not related. So that happens only in odd. Okay, so we will focus again on cube roots. So now let me write some general equation. X cube is equal to a cube. A is any real number, okay? It might be positive, it might be negative, okay? It might be positive, it might be negative. So what are the roots? If you solve this equation, you'll get x is equal to a and a omega square. Again, same method, you can factorize it. You applying the formula, and then you can write the root. You'll get the roots a omega square. So x cube minus a cube. Let me do it for you. If you factorize, you'll get x minus a and then x square minus ax plus a square. All right. So you write the roots of this, and you will come to know one root. You can easily see one root is a, and the remaining two roots will be a omega and a omega square. So this is an important equation. See, why am I telling you? Because sometimes you get x cube is equal to say 8. Okay, x cube is equal to 8. Now you study cube roots of unity. You do a lot of questions based on cube roots of unity. So you are very much familiar with these two relations. 1 plus omega square is equal to 0 and omega cube is equal to 1. Okay. So now suppose he is not giving you x cube is equal to 1, but he is giving you x cube is equal to 8. Okay. And then if you are not relating this with the cube roots of unity, then again you'll have to write 3 new roots, and those 3 new roots again you'll have to apply, I mean, whatever, suppose you need to find the value of some expression of those roots. You'll have to put those values and new values, and then you'll have to form new relations. Okay, so it's better to write these equations in terms of omega. How to write it? Use this equation. 8 can be written as 2 cube. Whether number is positive or negative, you can do it. All right, so what are the roots? Roots will be, we answer it, and roots will be 2 omega and 2 omega square. Got it? Now suppose you have x cube is equal to minus 8. Okay, then what will be the roots? So minus 8 can be written as minus 2 whole cube. All right, minus you can take inside. That's why I'm telling it is valid only for odd numbers. For even numbers you can't do that, right? Even numbers you can't do that. If it would have been x raised to 4 is equal to minus 16, then minus 16 can't be written as minus 2 raised to 4, right? That's why roots are not related of these two equations. X raised to 4 is equal to 16 and x raised to 4 is equal to minus 16. All right, while they are related when n is odd. I hope you have got it. So what are the roots of this equation, by the way? Yeah, so roots will be minus 2. First root will be minus 2, then minus 2 omega and minus 2 omega square. All right, so you can use this, and whatever is the expression of roots of this equation, you can write that expression in terms of omega and omega square. So I hope you have got these points, very, very important points. All right. Now suppose you try one question. Solve this equation. I'm giving you. Now I'm not giving. See, in this equation, a was a real number, right? A cube was a real number. So a cube real means a real, all right? So a was a real number, okay? A was a real number. So you could write the results. You could write the answers. I mean roots in terms of omega directly, okay? By using this relation, which I've told you here, generalized, all right? But suppose a belongs to, you have this a cube where a belongs to complex numbers, then you can write a omega square. All right, now roots will be different. How to find those roots? Okay, I'll tell you. So let's solve this equation. X cube is equal to iota. If you solve this equation, then you'll have to use that generalized method which I have told you while finding the cube roots of unity, the second method, in which we expressed the complex number written on the right side of this equation in terms of in form of Euler's form, right? The form of Euler's form. So iota can be written as modulus of iota is 1 e raised to I pi by 2. Pi by 2 is the argument of this complex number, plus you need to add 2k pi in this. All right, as simple as that. Now you can see x can be written as, now take cube root, so e raised to 1 by 3. If you take cube root, it is going to be 4k plus 1 divided by 2 into pi. 4k plus 1 divided by 2. But 4k, all right. Now if you put k is equal to 0, k is equal to 1 and k is equal to 2. Always if you are taking cube roots, then start the values of k from 0, 1 and go up to 3, write 3 values. After that repetition will start and same roots will start repeating. If you're finding the fifth roots, then in this equation you need to put I think this, yeah. In this equation, you need to put k is equal to 0, 1, 2, 3, and 4 if you're finding the fifth roots, all right? So by putting k is equal to 0, x1 is going to be, okay, just put k is equal to 0. It's going to be e raised to iota pi by 6, all right? All right, no problem. When you write second root x2, then put k is equal to 1, it is going to be e raised to iota 5 pi by 6. Now the third root x3 is equal to e raised to, if you put k is equal to 2 in this, that is going to be 9 plus 1 pi by 6. 1 minute. K is equal to 2, so 8 plus 1, 9, 9 pi by 6, alright? You can see difference of these two angles. Difference of these two angles is 2 pi by 3, right? And difference of these two angles is also 2 pi by 3. I mean this minus second minus first and third minus second. Iota is also there. If you try to plot these roots, these are not roots of unity. These are uh, cube roots of iota. And cube roots of iota, yes, you have understood the geometry, right? So if I make this circle, all right. So one root, your first root, in cube roots of unity, first root used to be 1. Now your first root is not 1. It is e raised to iota pi by 6. And yes, of course, we can write the value of this by using cos pi by 6 and sin pi by 6. Second value is going to be e raised to iota 2 pi by 5 pi by 6. 5 pi by 6. And the third root is going to be e raised to I 9 pi by 6. Now you can see this angle and this angle are still equal, all right? So it doesn't matter if they are cube roots of unity or cube roots of some other complex numbers. Okay, they will lie on the circle radius, whose radius is now radius will vary. Okay, radius will vary. That will depend on the magnitude of it. Okay, so if you are solving this equation x cube is equal to a cube, then radius of the circle will be mod of a. Like if you are solving x cube is equal to 8, then radius of the circle will be 2. Right? So accordingly, you can answer your question. I hope you got it how to find the roots. Okay, now you solve this last equation. Hmm. No. Wait. I'm sorry. This you can write. X cube is equal to iota. Okay. Now let's take some complex number. Okay, iota we have done minus some other complex number. Which number should I take? Uh, hmm, root 3 plus iota. So write this in Euler's form. Root 3 plus iota is basically e raised to I pi by 6 plus add 2k pi. Okay. Then x cube is equal to this. Then x can be written as e raised to I 12 pi plus pi divided by 12k pi, sorry. 12k plus 1 into pi by 6. Okay, this is what you will get. And yes, 3 also. Cube root. Now put k is equal to 0, k is equal to 1, and k is equal to 2. You'll get three roots, all right? And then if you put k is equal to 3, then roots will start repeating. So first root, what is the first root? If you put k is equal to 0 in this, that is going to be e raised to I pi by 18. Now second is going to be e raised to I. If you put 1, then that is going to be 13 pi by 18. And third is going to be e raised to I, right? So you can plot these roots, and first root will lie. Where is the first root? See, they will still divide this circle into 3 equal parts. I'll plot it fast. So like this. Okay, so where is the first value? First value is this one, e raised to I pi by 18, very small angle, something like this. Yeah, e raised to I pi by 18. Then e raised to iota 13 pi by 18. 13 pi by 18 is somewhere here. And 25 pi by 18, 25 pi by 18, where it is 25 pi by 18. So it is slightly less than this, something like this, all right? E raised to I 25 pi by 18. Okay, so you can see they are forming an equilateral triangle. Yes, but vertex of that triangle is not lying at this point. That's the only difference. 120, 120, 120. All right. So these are the roots. You can't express these roots in terms of omega. Yes, you can, but that it's easy to solve in this way in this question. All right. So that was it. We'll have a practice session for cube roots of unity later in upcoming sessions. I'll discuss the theory of nth roots of also and roots of unity also tomorrow, and then we'll do questions, a lot of questions based on omega and omega square cube roots of unity and nth roots of unity combined. All right. So practice session we'll keep later. This was the theory, and to revise it, and we'll continue tomorrow with nth roots of unity. All right. So thank you very much. Like the channel and subscribe the channel.